Hello and welcome back to another video of Wise Interactive Learning. In this video, we are going to see problems based on chain rule and also what we call is that box rule. Okay, so we have 5 examples over here and we'll take each and every example one by one and we will solve them by using chain or box rule. So the first is under root x plus 1 upon x. So we can simplify this by making x square plus 1 upon x, but it is going to be a tedious method. Rather, what we can do is we just consider this as y equals to x plus 1 upon x whole raised to 1 by 2. Now, since we know that anything which is f of x raised to n is nothing but n f of x raised to n minus 1 times f dash of x, it is going to be easy for us just to solve this example by using this formula. So we can do that. So we'll take 1 upon 2 below here and we'll write 1x plus 1 upon x 1 upon 2 minus 1 times the derivative of this inside function. So derivative of x is 1 and 1 upon x is since this x will 1 upon x can be written as 1 upon x can be written as x raised to minus 1. So this will be 1 minus 1 upon x square. So this is your final answer and in one step we have got it. So we just need to simplify this. So it will be 1 upon 2 x plus 1 upon x raised to minus 1 by 2 times 1 minus 1 upon x square. So this is your final answer. Now we'll see the second question. So the second question is y equals to under root of sine x. We know that this can be also written as sine of x raised to 1 upon 2. So the differentiation will be, or rather what we can say is y dash will be, see 1 upon 2 sine of x raised to minus 1 by 2 times the differentiation of sine of x, which is cos of x. In other words, we can write this as 1 upon 2 under root of sine x, and here you can write cos of x. So this is your final answer. For third, we have y equals to cos of under root of x. So it is easy as that. Y dash will be, differentiation of cos is minus of sine, so minus of sine under root of x times you have to take the differentiation of root of x, which we directly know it as 1 upon 2 root x. So here is your final answer. In the third, we have y equals to sine of x square plus 5. So this is a direct formula where we have function as sine of f of x. So we have y dash equals to the differentiation of sine of any function will be cos of any function, which is x square plus 5. Then we again multiply it with 2x plus 0, or rather just 2x. So 2x cos of x square plus 5. Again, this is kind of tricky where you don't have an integer in the power, and this is going to be a tricky situation for some people, but trust me, it is the easiest example of all. So we have y equals to sine of log of x. So since it is raised to 2 by 5, we can use the box formula. Just keep 2 by 5 over here. So it is easy for us to understand that this is the complete f of x raised to this n power. And remember that each and every time this power given over here, this particular power is never going to be an integer. Like, it is not compulsorily going to be an integer. It can be anything, 2 upon 5, 3 upon 5, 17 upon 18, anything. So y dash will be 2 upon 5 comes down and we have to subtract 1. So sine of log of x and then subtract 1. So if we subtract 1 from 2 upon 5, what we have is minus 3 upon 5. So it is minus 3 upon 5. Then multiplied by, when you get this f of x, you have to differentiate this f of x, and the outer box is of sine. So the derivative of sine is cos of log x, and then you again go inside, the derivative of log of x is 1 upon x. So this entire equation will be divided by 1 upon x. So that's your final answer. Now we have seen few of the examples like these from the Maharashtra State Board 2.2 exercise. Now we'll go on to see what are the different examples as opposed to the logarithmic differentiation which we have seen in the last video. Now we have to see all these examples by using log, and it's pretty much clear that these are necessarily some of the functions where it is function raised to function problems. So here we have 1 plus 1 upon x raised to x. So it is mostly a problem where it is given as function raised to function. So we can take it as y equals to this entire function. So I won't rewrite it. I just need to cancel this out. So let's take this as y. So we can say that log of y, it will be immediately x log of 1 plus 1 upon x, and we just need to differentiate this, and we know that on the left hand side it will be 1 upon y and y dash equals to x, then again 1 upon this entire term. So it will be 1 upon, so if we just look at this example, it is x plus 1 upon x. So if we take it down over here, it will be x plus 1 upon x. So that x will go in the numerator. So it will be times x plus, now we have to keep this term constant of log. So we have this times 1. So you have x square plus x square upon x plus 1 plus log of 1 plus x, and this is your final answer. Y dash will be, you have to multiply y on the both sides since you have y over here. So y is nothing but 1 plus 1 upon x raised to x times x square upon x plus 1 plus log of 1 plus 1 upon x. So this is your final answer. Isn't it easy that we have done it within just two steps, like 2 steps. Now we'll see the second problem. So we have this second example as y equals to sec square x raised to 1 upon x. So we can just have to kind of rewrite this. We can say this as y equals to sec of x raised to 1 upon 2x. So can we do this? Yes, because we are just using the properties. So log of y, so this left side will be permanent as it is going to stay as it is. So 1 upon 2x log of, so since we have taken log, it is log of sec x. Nice. So on the left hand side we know that it is going to be 1 upon y times y dash, which is the required function. So this is what we actually require. So differentiating this 1 upon 2, we need to keep constant 1 upon 2x times differentiation of log of sec x will be 1 upon sec of x times differentiation of sec of x is sec x times tan x plus, now this time we have to keep the log term constant, which is log of sec of x times, we need to have the differentiation of 1 upon 2x. So 1 upon 2x is necessarily the differentiation will be minus 1 upon, it will be minus 1 upon 2x square. So this is the differentiation. So what will be our final answer? It will be y dash equals to sec square x raised to 1 upon x times, so here if you look, this sec of x and this sec of x will get cancelled. So you only have tan of x divided by 2x. So you have tan of x divided by 2x as the first term, and the second term will be, this negative sign will prevail over here. So we don't have this plus sign, so it is negative. And then in the numerator we have, log of sec of x, and in the denominator we have 2x square. So even from this you can do a thing like you can take 2x as common from these two terms and just put, you can take 2x as common and you can bring it out or you can just simplify as it is. So the third problem is very easy, but we need some kind of simplification over here. So it states that it is e raised to log of x and times log of 3x. So here some kind of simplification is required, and as we know that when you raise a function to the power of e, for example, if we have e raised to log of f of x, so this is another formula which we need to learn. In such kind of examples, what is going to happen is, since the natural log over here is e, we know that this function can be stated directly as f of x. Why? There's a very simple example, and we can prove this in very least amount of time. So I'll just show you how it is done. So let's take an example where it is e raised to log of sin x, and this value let's say it is k, right? And if I take log of log on the both sides, so what is going to happen? If we take log on both sides, it is going to be log of e raised to log of sin of x, right? And on the right hand side it is going to be log of k, isn't it? But you know that when we have power in the logs, we can take it down, like we can drag it to the over here. So it will be log of sin of x times log of e equals to log of k, isn't it? But we know that log of e is nothing but 1, right? And then we have log of sin of x is equals to log of k, and we have a direct clear answer over here. It is that k equals to sin of x. So hence we have the proof that this function can be directly stated as k equals to sin of x. So from this, if we look at the original example which we have, I'll just rub this off. So if we look from that perspective in this question, we have this f of x as log of x. So we can directly say that this example is log of x times log of 3x. And now you can use the product rule, which is this is u and this is v. So y dash will be, first keep log of x as constant and then differentiate log of 3x, which is going to be 3x upon 3. So 3 gets cancelled, plus log of 3x as constant upon x times 1. So your final answer is y dash equals to, so since we don't have to take any log, it is a direct calculation problem. It is nothing but log of x upon x. So 1 upon x can be taken as common, log of x plus log of 3x. So even this question was from a standpoint of taking log. You can see that we can solve this example just by using product rule. So the answer is going to be same, and also we can simplify this answer further, which is y dash equals to 1 upon x, and we know that log of a plus log of b can be stated as log of a times b. So it is going to be log of x times 3x will be 3x squared. So this is your final answer. Now we'll take the fourth example, which is e raised to x, which is y. So if we take y equals to e raised to x, and if we apply log on both sides, it is going to be log of y equals to x raised to x log of e. And here you can see that log of e is nothing but 1, and we also know that differentiation of x raised to x is nothing but x raised to x 1 plus log of x, right? So again here, if you directly know that differentiation of x raised to x is x raised to x 1 plus log x, it is fine. But here you can do another step, which is again applying log. So this is the second time when you apply log. So you can say that log of y will be x log of x, and here from here it is easy differentiation. So here you can say that log of y, you can state it as 1 upon log of y times 1 upon y times dy upon dx, or rather the required particular y dash. and here you can see it is as x. If you keep constant, it is x upon differentiation of log x, which is 1 upon x, plus log of x as constant. So this is your 1 plus log x over here. But we know that log of y is nothing but x raised to x, right? So we have this in this step. So the final answer will be, I'll just drag this down. So the final answer will be dy upon dx. It will be log of y times 1 plus log of x. So what is y? Y is nothing but e raised to x raised to x. What is log of we have y as e raised to x, and what is log of y? It is x raised to x and 1 plus log of x. So this is your final answer, which is y dash. Now we'll look at the fifth example. So just try to bring this down. So now we have the fifth example, which is cos of x raised to x, and in the denominator we have 1 plus x minus x square, which is y, right? So we can say that log of y is equals to, since we have numerator and denominator, we know that we can say this as log of cos of x, and here x, since the power comes down, minus log of 1 plus x minus x square. Now here we need to understand, we have to use different formulas. Here we need to use the product rule, here we need to use the box rule, and this combined effort is going to solve the question of a logarithmic differentiation rule. So we have 1 upon y, then times y dash, which is equals to x, then differentiation of this will be cos of x times minus sine of x. So this is nothing but minus tan of x, and then we have plus log of cos of x, which is the second term, minus this entire term will be 1 upon 1 plus x minus x square, and the differentiation of it will be 0 plus 1 minus 2x. So this is 1 minus 2x. So now we need to simplify this. So if you look carefully, here we have minus of sin x, and then we have cos of x. So this is minus of tan x. So instead of writing this term as first, we can write this term, which is log of cos of x, as first, and then we can write the second term. So it will be log of cos of x minus x tan x minus 1 minus 2x whole divided by 1 plus x minus x square, and then we can multiply this term by y, since we have y dash over here. So what is y? So y dash will be, y we have as cos of x raised to x, everything divided by 1 plus x minus x square, and then this entire term will again come down, log of cos of x minus x tan x minus 1 minus 2x completely divided by 1 plus x minus x square. So these are few examples which we have taken from the exercise 2.4 of the Maharashtra State Board, and these are quite simple and fundamental questions which we need to learn about differentiation. These are not going to help you in terms of JEE or mains level or advanced level, but they are surely going to help you in terms of board exams and clearing the fundamentals, which will help you to necessarily have an intact, thorough intellect about solving the JEE, mains and advanced level problems. Thanks for watching, and see you in the next one.